So this is 1.6, the problem set in elementary algebra. First thing you're doing, 1 through 6, you're labeling those numbers as prime or composite. So you can just use a P or a C when you label those. Now remember, a composite number is a number that is not prime. Every even number is composite because 2 goes into it. There's a lot of other prime or odd numbers that things go into it besides 2. So like 5, you have 1023. 2 does not go into it because it's odd, but 3 does go into it. And let me show you one little trick that you can maybe already know to figure out if it's 3, because you can just, or if it's prime, because you can figure out immediately if 3 goes into it. If you take each of the digits and add them up, and in this one we get 1 plus 0 plus 2 plus 3 is 6. And the answer, if 3 goes into the answer, then 3 will go into that. So let's try it. 1, 0, 2, 3, 3, 3, 9, 1, 2, 4, 12, 3, 1. 341 times, evenly. So see how I did that? 1 plus 0 plus 2 plus 3 is 6. 3 goes into 6, so 3 goes into that. And that's just a real quick, easy way to find out if 3 does. You know, you have to try some other things to see if like 7 and 9 and some of those go into it. Because like number 6, 5 plus 4 plus 3 is 5 plus 4 is 9 plus 3 is 12. So 3 goes into 12, so 3 goes into 543. So you're not necessarily trying to find out which number, or you know, what numbers go into what how many times. You're just interested in finding out if they're prime or composite. So that's 1 through 6. 7 through 22 is you're factoring them into the product of primes. So let's take one like 598. And that is number 20. So 598. I know 598 is an even number, so I know 2 goes into it. But how many times does 2 go into 598? Well, let's see what we can do. 598 divided by 2. And I like a calculator for this. 299. 2 goes into it. And 2 is prime, so let's circle it. 299. Does anything go into 299? Well, I mean, your options are pretty much 1, 2, 3, 4, 5, 6, 7, 8, 9. And I know 2 doesn't, I know 4 doesn't, and I know 6 doesn't, and I know 8 doesn't because it's not an even number. So then I try 3. Nope, that doesn't, because 2 plus 9 is 11, plus 9 is 20, and 3 does not go into 20, so it doesn't go into 299. Doesn't go into 5, or 5 doesn't go into it because it doesn't end in a 5 or a 0. 7 and 9 are the only ones that you can try, and I tried those and nothing did. So those 2 are my prime factors. Let's do one like number 22, 2,310. Well, I know that 10 goes into it because it ends in 0. So I'm going to divide that by 10. So I get 231 and 10. Well, I know 10 is not a prime number because 2 and 5 go into it. But those are both prime, so I'm going to circle them. I'm done there. All right, 231. 2 plus 3 is 5 plus 1 is 6. So 3 goes into 6, so I know 3 goes into that 77 times. And that is prime. This is not. But now these 2 numbers are. So for 2,310, I've got 2 times 3 times 5 times 7 times 11. Those are the prime factors of 2,310. And notice I put the numbers down there in numerical order there from smallest to largest. 23 through 34, you're reducing those fractions. Good to be familiar with how to do that. So that's the reduction of fractions. 37 to 42, write each of the following fractions as an equivalent fraction with a denominator of 24. So if you have a number like 3/4 and you want the denominator to actually be 24 instead of 4, what did you do to get from 4 to 24? You multiplied by 6. So you multiply the top by 6 and you get a fraction that has as a denominator 24. You do the same thing with 43 to 46. You take a number like 3/5 and they want to change that, so 60 is on the bottom. What did you multiply 5 by to get 60? And that would have been 12. So you multiply the top by 12 and there's your fraction with a denominator of 60. 47 to 50, you're trying to decide which one is bigger. So if you have negative 3/4 and negative 1/4, decide which one is bigger. Kind of hard when they're both negative, isn't it? Because you look at 3/4 and it's like, well, 3/4 is bigger than 1/4, but all that means is on the number line, 3/4 is further away from 0 than 1/4 is. So actually, the number to the right, when you put them on a number line, is the biggest number. Okay, so when you put two numbers on the number line in the right place, the one to the right is always the bigger number. The one to the left is always the smaller number. 51 to 62, you're just multiplying those. 63 to 68, you're expanding and multiplying. Let's look at 64, 5/6, and we're squaring that. Whenever you square a fraction, you square the numerator and you square the denominator, and you're done. 69 through 78, multiply the following. Alright, 76 is negative 2 over 5, and it's the quantity squared. So we're going to take what's inside here and square it. Negative 2 times negative 2 is positive 4. 5 times 5 is 25. So that's what we get for an answer there. We could have done, and put the negative down there. 2 times 2 is 4. Negative 5 times negative 5 is positive 25. So we get the same answer. It doesn't matter if the negative's down here or the negative's up there on the 2. It does not matter at all. Another one that might be a little bit confusing is 77. Okay. We're going to make that into a fraction. Whenever you're multiplying a fraction times a whole number, just make the whole number into a fraction like that. Multiply the top. Negative 1 times negative 3 is a positive 3. That x, you can't do anything with it. It's being multiplied by the negative 3. There's nothing else to multiply it by, so it just kind of tags along. Denominators you multiply. So you get 3x over 3. And what is any number over itself? 1. So we get 1x, or just x. Okay, let's see here. 79 to 88. If we have a number like 6 over 8 and it's being divided by 3/4, we just take that, turn it into a multiplication sign, and turn the second fraction upside down and multiply. 24 over 24, any number over itself is 1. If we have something like 84, 84 is 5 over 12 divided by negative 10 thirds. Exactly the same thing. We change our division sign to a times and switch this upside down and multiply. 5 times 3 is 15, which is a negative, over 120, and then you reduce that from there if you can. 89, what you're doing there, if you remember right, is let's take 89b, 8 divided by 4/5 minus 10. PEMDAS says you do your division first. So we're going to do 8, we're going to make that into a fraction, divided by 4/5, which is 8 over 1 times 5 over 4, which is 40 over 4, which is 10. And then we're going to subtract that 10 from it and get 0. So one last one, let's look at 119. 5/12 minus -3/8. Two minuses. So that turns it into a plus. And let's make that look like an actual 5 there. Alright, so we have to make common denominators here before we can add those. So the 12 is 2 times 2 times 3. And the 8 is 2 times 2 times 2. So we're going to look at the 2's in the top and the 1's on the bottom. 3 times down here, only twice up there, so we throw those out. So 2 times 2 times 2 is what we're keeping. And we have a 3 up here, but we don't have any down there, so we want the 3. So 2 times 2 times 2 is 8 times 3 is 24. So my common denominator is 24. So we change this 12 to a 24 by multiplying by 2. So we'll multiply the top by 2. And then we change the 8, I guess this 8 doesn't matter, to a 24 by multiplying by 3. So we multiply the top number by 3. So we have 24 on the bottom and 9 on the top. So 10 plus 9 is 19, and the 24 plus 24 we don't add because it's in the denominator, and that's what we get for an answer. So that's some problems from 1.6 that should help you.